All right, you are welcome back. We are still in amortization, and this time around we are going to be talking about using the formula for it. This is session 5.5. Okay, so sometimes we are looking for a specific and not the full schedule, some specific values. Okay, in the amortization schedule, so there's a need to use some formulas. So these formulas come handy in such situation. Okay, also there's some amortization schedule that we cannot be writing the whole schedule on paper because they have a lot of periods. So because of that, we can just quickly use the formula to calculate that. So the first one is the formula for our repayment, which in this case, this is an ordinary annuity. Don't forget, in the previous video, we mentioned that you can either use ordinary annuity or annuity due depending on if the question states at the beginning or at the end. Okay, so this is for ordinary annuity, which we are going to be using always to calculate your R, your payment. Going to be using to calculate your payment. The second one is the principal outstanding. Principal outstanding, okay? The principal outstanding at the beginning of the Kate period. Okay, so we use this formula for principal outstanding. Principal outstanding at the Kate period. Okay, principal outstanding at the Kate period. Okay, so please take note of the formula. The formula is similar to this, only that now you are now adding K and then subtracting 1. And this K is at the beginning of Kate period. Okay, let me now explain something about this principal outstanding. In this principal outstanding, the beginning of Kate period is the same thing as the end of K minus 1 period. K minus 1 period. Okay, so please take note of that. So if I say calculate the principal outstanding at the beginning of the 10th period, this principal outstanding at the beginning of the 10th period is the same principal outstanding at the end of the 9th period. Please take note of that. Principal outstanding at the beginning of the 10th period is the same principal outstanding at the end of the 9th period. So I can change this to principal outstanding at the end of the K minus 1 period. Okay. Please take note. Only principal outstanding has that variation or that consideration. Please take note of that. All right. So another formula is the formula for interest. Number 3, formula for interest in the Kate payment. Okay. Again, the same formula, but you are now again adding K minus 1, then multiplying by R. So please take note of the formula. You need to know these formulas. Please, you need to know the formulas. Okay, number 4, principal contained or principal repaid. Principal repaid in the Kate payment. In the Kate payment, you multiply by R, then you subtract them from 1. Okay, and then the last one is the total interest. The total interest. Okay, the total interest is given. This total interest is also called finance charge. Finance charge. So the total interest is also called finance charge. Okay, so you need to know this formula in case any question we ask you to use them when you cannot draw the amortization table for such things. Okay. All right. So let's take this question. A borrower is repaying this loan at 9.5% per year, compounded monthly, with monthly payment over 20 years. So the first thing, determine the monthly payment. Okay, look at the question. The question did not say at the beginning, so we use ordinary annuity. It didn't say in advance, so we use ordinary annuity and not annuity due. Okay, so we have the formula. Please take note, we have the formula. N is 20, but it's compounded monthly. So our M is what? Is 12. Our N is 20. Our A is that money we borrowed. Okay, and our R is 9.5%. So we put that into the formula and then we calculate for our R. So every month we're going to be paying this 6,000 plus. Okay, every month, almost 7,000. We're going to be paying every month. All right. So now, question 2, determine the balance outstanding after the 70th payment. Don't forget balance outstanding or principal outstanding after the 70th payment. That means we are looking for principal outstanding at the beginning. At the beginning of 71 payment. Okay? Don't forget principal outstanding or balance outstanding at the end of 70th payment is the same as the beginning of 71 payment. Okay, so our K there is 71 and not 70. Our K is 71 and not 70. Okay, so we use that formula for principal outstanding or balance outstanding, and then we get this. So our balance outstanding at the beginning of 71 payment or at the end or after the 70th payment is given as this. Is given as that. Okay, please ensure you understand. Okay, number 3, we want to determine the interest contained in the 20th payment. So here, interest in 20th payment, our K is 20. So we use the formula for interest contained, and then this is the formula for the interest contained in the 20th payment, in the Kth payment. The interest contained in the Kth payment, we use that formula, and then we get our value to be this. That is the interest in the 20th payment. The interest, can you see, is a lot in the 20th payment. Okay. All right, now again, we want to find the principal contained in the 30th payment. That means the principal repaid in the 30th payment. So we use the formula for principal repaid in the 30th payment. So that is K equals to 30. We use the principal repaid in the 30th payment, and then we substitute our value there, and then but don't forget our R. R is what we calculated first, and that is all what we are using. We are using our R. We are using our R. We calculated R first. We are using our R. Okay, please take note of that. All right, so the last one, we want to determine the finance charge. I did mention that the finance charge is the same thing as the total interest. Total interest. Okay, the total interest will be, we use the formula, and then we get this. You see, the interest is even more than the money that was borrowed. You see, so that is the interest that we are going to be paying to the bank for borrowing us that money. Okay, please ensure you understand, ensure you know how to use the various formulas. Thank you.